Hi, I'm Ryan, Director of Training with Standard Motor Products, and today we're going to be talking about one of those topics that probably make technicians' brows sweat and get nervous. No, I'm not talking about communication diagnosis, but we're talking about key-off EVAP. You know, a lot of people, their nightmares are wondering what goes on in their house while they're asleep. Well, if they only knew what happens out in their garage while they're asleep, it might be even more of a nightmare, or it's a nightmare to technicians here. Yes, key off natural vacuum leak systems. When we're diagnosing EVAP systems, the car is out in the person's garage or out in the parking lot overnight running tests and determining if there's an EVAP leak or not. And so in today's session, we're going to talk about how these systems operate, operating conditions, and how we as technicians can effectively diagnose this. So let's get started. All right, well, let's get rolling with the presentation here. So when it comes to evaporative emissions, it's not like customers come in and say, my car pulls to the left, or it bounces excessive, or it makes a grinding sound. Like what we get with other concerns from customers. Usually the point of contact here is gonna be the check engine light. The customer is gonna call and say, hey, my check engine light's on, I need this diagnosed. Or, you know, there might be some additional symptoms with it. It's hard to put gas in it. It's extended crank in the morning, stuff like that might be related to the EVAP. But our main point of contact here is gonna be the check engine light. And so looking at EPA regulations here, one thing to clarify is the EPA kind of tells the vehicle manufacturers, here's a couple things you need to test for. They're not going to say how to test for it necessarily, but they're going to say the vehicle must pass these thresholds, and that's what it's going to take to keep the check engine light off. So the first thing is to verify purge flow. Now, different manufacturers will do this differently, and so that's where it's very important, and you'll hear me say this time and time again, always look up specific service information for the exact vehicle you're working on. I, as a technician, have been in trouble in the past going, yeah, I'm pretty good with GM, I understand this. And go, oh wait, this one does it differently. And so we wanna always look up, how is the monitor run for the particular vehicle you're working on? How are they testing for purge flow? Next mandate is that there's no leaks into the atmosphere here. And so that's really what we're gonna focus on in today's session here, is different ways in which different manufacturers use key off EVAP diagnosis here. And then the third thing is the components are going to be monitored for circuit continuity, out of range values, rationality, proper functional response, and there's going to be some more stuff there. So that's really the mandate that vehicle manufacturers are given. You have to do these three things when it comes to your EVAP. Now, as vehicles have progressed, now obviously the tolerance for those leaks have gotten smaller. So systems have to be a little more precise and a little more exact in this. And obviously the processors, the computers on the vehicle are much more advanced here. So when it comes to EVAP, there's really two core components here. First is vapor storage. That's what EVAP's all about, right? Is containing those hydrocarbons, keeping them from going out into the atmosphere. And so it's about vapor storage, but also vapor removal. That canister can only hold so much effectively. At some point it needs to be consumed, or something has to be done with them. And so that's where we get vapor removal through the purge solenoid typically. So the storage system, that canister, is made up of activated charcoal. And so this is small beads. I've got a cutaway canister here, but in the interest of making a mess in our whole studio, I left that in the closet today. But if you crack one of those things open, you'll actually see all kinds of small pellets of charcoal. And if you're familiar with some of the earlier canisters, they were pretty large in size. Today's are much smaller, but what that means is there's more surface area there for the hydrocarbons to latch onto here. And so the second bullet point here where it says large surface area, that doesn't mean big, it means a whole lot of small ones together add up into a large surface area. And that's going to adsorb, not absorb with a B means it's going to take it in. Adsorb means it's going to kind of latch onto it, and it's going to stay on the surface here. And so if we look at the system here and system schematic, and so, we've got the user putting fuel in the tank right here. And so the fuel is going to come in. If this tank is empty, it's going to be full of air. And so that air has to go somewhere. Pre-EVAP days, that would just go out in the atmosphere. And so that's where if you're at the gas station, I've got my 70 Chevelle, and you put gas in that thing, you see kind of the vapors escape into the air. Today's modern vehicles, we just don't see that. So as fuel comes in, it's got to displace that air somewhere. So now that air is going to go into the vapor canister. And so that fuel or the hydrocarbons will be adsorbed or stick to that charcoal there. But at a predetermined time, now we need to clean out that canister and desorb or get rid of the hydrocarbons out of that particular canister. So we've got the Purge solenoid here. It's going to be connected to intake manifold vacuum. Now, that's the traditional system. Today's modern vehicles, we see a lot of turbocharged vehicles in which this isn't necessarily going to be under vacuum. It might be under boost pressure at certain times. So if you want to learn more about that, I did a session on that a couple months ago. And so go to our playlist. You can find that there and learn more about EVAP on turbocharged vehicles. But for most vehicles, we're going to have manifold vacuum here. The Purge solenoid will be turned on. And so what that's going to do, it's going to draw fresh air in through the canister vent. And that fresh air will go into the canister. It's going to grab onto those hydrocarbons, and that will all be drawn into the intake manifold. And so that's going to burn that fuel off there. And so there, in a nutshell, is how we're going to track or trap the vapors, and then how we're going to remove them there. So when it comes to manufacturers and the trouble codes that they're going to set here, remember, most of these EVAP systems are being continuously monitored, especially for circuit codes. Some of these additional leak tests will be monitored under certain conditions here. Talk about that in a little bit. But the circuit codes definitely are going to be continuously monitored here. And so the control module is simply looking for a value outside the normal range of operation in a particular circuit. So here we've got our canister vent. We've got the wiring going to it, going to the PCM. Now that's very typical and traditional. And so the PCM is going to be monitoring the circuit here for any shorts or open circuits. One interesting little note, if you're working on a modern GM, like a 2020 or newer, many times the vent control solenoid is actually going to be controlled by the fuel pump control module. Now, we always think about these being PCM controlled, and they have been for many years, and many manufacturers still do that. But General Motors actually made that change around 2020 on certain models. So don't always assume it's going to go to the PCM. Take a look at the wire schematic and get a definite understanding of where that circuit is being operated from. Then performance codes. These are going to be monitored when certain components are turned on and off. Did the system react to the way that the control module expected it to? And then today's topic, we're going to be talking about leak codes and how different manufacturers detect particular leaks here. And so a code will be set if they detect the inability to build and maintain vacuum or negative pressure. And we're actually going to be talking about positive pressure in the fuel tank here today. So why positive pressure? Well, that seems counterintuitive, and that's the reality of what many manufacturers have been doing really since the early 2000s when it comes to ideal gas law or natural vacuum leak detection systems. Different manufacturers call it different things, but let's walk through a little bit of this here. And so when it comes to ideal gas law, you got to keep in mind that the gas, I'm not talking about the fuel, gasoline, but gas as in a state, not a solid, not a liquid, but it's a gas. And so even in this room here, we have air. And so this stuff that's in the air is always in motion. But now as it gets warmer, this stuff is going to increase in speed. And so the air particles are moving faster and faster. And then as it gets cooler, it's going to decrease in speed. So speed equals energy, and then energy equals pressure. So think about if you've taken a balloon, let's say, it's winter time right now. Some areas of the country are super cold. Some are not so cold. If you take the balloon outside in a cold area, what's going to happen? It's going to shrink. If you take it outside in a warm area, it's going to expand. And so that's kind of the ideal gas law here. Now, as we apply this to a vehicle sense here, we've got our sealed fuel tank here, which should be a fixed volume. It's not, going to expand or contract. It's a steel tank or a heavy duty plastic tank. And so if we're at a fixed temperature, now we're going to see a fixed pressure. However, as the vehicle sits out in the sunlight or it's driving on warm pavement and it's reflecting heat up there, if that's still a sealed system, it's now going to build pressure in it. And manufacturers are going to recognize that, and that's being used here. We're traditionally, most technicians think about kind of like the GM purge and seal method, where you're drawing a vacuum in the system and then you're shutting it off and you're maintaining that. That works for many manufacturers, but in today's systems, they are now using the pressure here in the key off system as mentioned. So now, as that same vehicle is parked and it starts to cool down overnight, the sun goes down, it typically gets cooler overnight. Now, if that system is still sealed, we're going to see it go from a positive pressure into a negative pressure there. And so that's kind of the whole theory behind ideal gas law. And that's what's going to be used time and time again by different manufacturers in different ways here. So let's just look at a couple of the popular ones here. Obviously, the first one here is going to be General Motors. And so, as mentioned, they typically have always used the purge and seal method, where they're going to turn on the vent solenoid, sealing it off, and then they're going to turn on the purge solenoid to draw a vacuum, and they're going to then turn the purge off, and we'll have the vent solenoid closed. So both the front and back side of the system are closed off. We want to make sure that we can maintain it there. And so around early 2000s, 2003 is the first one I've ever run into myself on a GM product here, where they started using engine off natural vacuum. And so that's what's going to be used for detecting these small leaks here. We got to pay attention to if there's a vent code, or there's quite often GM is known for restricted vents, especially in the trucks. Hopefully many of the new trucks out on the road today have the updated vent assembly on them, which is going to prevent them from being restricted here. But be aware, if you have false vent codes, we need to address that before anything else can be done. And then a big question from a lot of technicians as we talk about EVAP codes, especially in these type of systems: what about the decay time? How long is long enough to hold it here? The answer is it depends. So now if we've got a full tank of fuel, well, there's only a small amount of air in there, and so the reaction time is going to be much different than if the tank is very low. And so if we have a tank with a small amount of fuel, there's a lot of air, and there's a lot of flexibility in there, fluctuation. So that decay time is going to depend primarily based upon the fuel level, and take into consideration the external temp. So myself being from Michigan, we don't see a whole lot of EVAP codes in the wintertime. Now I'm here in the studio today filming from Texas, where it is 74 degrees. And so EVAP systems are being monitored. That's something to take into consideration as a technician when you're working on these things, is what's the enable criteria for these monitors to be run? If it's too cold, it's going to be inhibited. The system's not going to be testing for EVAP system. So the worst thing we can do as technicians go, well, we put some new parts on it, give it back to the customer and go, it never came back. Well, it might not have run the test itself. So that's where we have to do our due diligence and make sure that we've tested the systems ourselves and test them again. Because that monitor might not run again until April if you're in a cold area. So if you're somewhere in the south, you need to kind of keep that in consideration too. If you're in Phoenix and it's 117 degrees, that system might not be testing at that point either. And so keep that into consideration. Always look in service information to determine the specifics for the vehicle you're working on. So now as we look at a complete GM system here, we've got the up arrows, which are going to be the inputs to the PCM here. And so we've got our fuel tank here with our onboard vapor recovery system, make sure it doesn't overflow. You have the fuel tank pressure sensor, which is one of the primary inputs to the PCM. It might be located in one of the hoses here. It might be located on top of the fuel pump assembly, depending on the vehicle you're working on. So we've got our EVAP canister here. We've got our engine with the intake manifold connected to the Purge control solenoid. And so we've got a test port here, but really on a lot of the modern GMs, really don't see a test port included anymore because we're doing a lot more and more testing with our good friends, the scan tool here. And so on older vehicles, yeah, everybody like to rush to the smoke machine. Primarily, I'm going to be using a scan tool for the first couple steps and really throughout the entire process here. So there's a lot more we can do now without running to our smoke machine. But we've got the canister filter leading into the canister vent solenoid. So here's our fresh air path going into the canister, and then it's going to go through to the Purge solenoid right there. So there's kind of our GM components. But let's look at what GM does for a Purge solenoid valve leak test. Now that goes back to one of those performance codes I talked about earlier, remember? And so being a P0496, a generic code, and want to make sure that Purge solenoid is sealed. Now, if you're familiar with GMs, you know that a lot of these things do have Purge solenoid issues or potential leaks. And so here's my commercial today. We as standard do have an updated, better designed Purge solenoid for these GM vehicles. But the way it's going to be tested, the vent solenoid will be closed or turned on, right? This is normally open in the off state. So the PCM is going to, or the, as I mentioned earlier, the fuel pump control module might apply power to it so that solenoid will be energized and close off the vent system. And then the Purge solenoid will remain in the off position. Now at this point, we should not see increased vacuum, right? However, if the fuel tank pressure sensor indicates the vacuum is increasing, or actually the level is decreasing, it's going to indicate that the Purge solenoid is stuck on, or it's leaking. It's sending vacuum to it at all times and purging really when it shouldn't be. And so that's how this particular code will be set. Now, when it comes to a large leak code, everybody's friend, the P0455, it's going to be done a little different here. So the vent solenoid will be closed or turned on, energized. So we've sealed off the back side of the system. Now the Purge solenoid will be turned on. So we're going to apply vacuum to the front side of the system. And now we should recognize that there is vacuum being applied to the system. If the vent is closed and the Purge is turned on and we do not see an increase in vacuum, now it's going to detect or set the trouble code that a large leak has occurred. So this might be a cracked line. This might be a cracked canister. Maybe the vehicle's in a collision, or again, going back to Michigan, we have a lot of potholes and a lot of road debris and damage. Somebody may have hit something, or the gas cap is off, or something indicating that a large leak has occurred. But it gets a little trickier when we start talking about the small leak, because rather than just a huge leak, now we're talking about a 20 thousandths leak, which is very small here. And so the early GMs used an enhanced version of that Purge and seal, or got a little more specific on how long it took to draw a vacuum or how long it would maintain the vacuum there. But early 2000s, they switched over to the engine off natural vacuum system, as mentioned earlier. And so this is being done with the ignition off. Typically it will take up to 45 minutes for this to complete. And then it can be done twice within a 24-hour window. So it's about 17 hours in between tests here. And so if it takes multiple, and I say multiple because some vehicles will set it on one trip, some will set it on multiple trips. So it might take 2 trips to actually set the trouble code here. So again, this is the dangers of replacing a component and giving it back to the customer and going, yeah, it must be fixed. I haven't heard from them in a couple of days. Well, it may not have met the conditions to run these tests here. So this is what I talked about earlier too, about customers are at home and their vehicle's out in the garage or out in the parking lot doing stuff while they think it's turned off. This vehicle is truly waking up and running some tests and engaging and turning stuff on and off and making decisions while the customer is sleeping comfortably in their bed. So as we look at the timeline here of how this test is run, so if we start here when the vehicle is shut off, now keep in mind there's going to be some pressure. Remember, the vehicle is sloshed around, is driven. Let's say it's parked in a asphalt area, so it's parked on top of some nice warm asphalt. As the vehicle is shut off here, now we've got our atmospheric pressure on this line, our vacuum threshold on this line, and then our pressure threshold here. So we can see that the system's going to do a volatility test here first and foremost. And so it's going to just sit there as is and see what happens. If we've got a summer blend of fuel, it's going to be a little more volatile. And so it's going to understand where some of these pressures go and what happens here. Well, as that starts to dip off over time and gets back to atmospheric pressure, now the vehicle will turn on or close the canister vent solenoid. So we should have a sealed system, right? The vehicle's turned off. The purge is going to be closed. By now closing off the vent solenoid, we should have a sealed system. And depending on the volatility of the fuel, with it now being sealed, we should see somewhat of a pressure increase. Now, we're not talking pounds of pressure. We're talking inches of water pressure here. So there is a pressure threshold. And if it does cross that, the test will be abandoned at that point. It's now a passing test. We're good. The vehicle can continue to go back to sleep. But if it does not pass that pressure threshold, now the canister vent will be opened up. So we're going to go back to atmospheric pressure right here, and then it will be closed again. And now as that vehicle continues to cool, what should happen to that pressure? That's right. We should see a vacuum start to pull on that as it continues to cool. Remember my earlier slide with the hot and cold. And so as this thing cools off, it should pull a vacuum. And once it crosses the threshold here, now it will open up and go back to atmospheric pressure and set a passing flag. But if it does not cross either of these thresholds here, it's going to set a pending DTC. And in most cases, it will try again within or outside of a 17-hour window. And so it's not going to just do back to back. It will set a flag if it doesn't set now. Who knows what happens throughout the next day as somebody drives it. At least more than 17 hours later, it's going to rerun it and see what happens. If it fails it again, but it passes the large leak test, now it will set a small leak trouble code here. So hopefully you have a little better understanding of how engine off natural vacuum is used here in a General Motors application. So as technicians, what do we do here? Well, we're still going to be doing the purge and seal. Use your scan tool bidirectionally, turn stuff on and off here. Can we hear the solenoids click? What happens at like 30% purge? I kind of like to use that as a rule of thumb. If I have to go up to ramp up to full on purge, turn it on completely, well, chances are I've got somewhat of a leak. Usually depending on the fuel system level and the exterior temperature or ambient temperature, that will give me a good clue as to how much purge I need to use here. So the manual engine off test, well, we can run the vehicle, build some heat in the system, then we're going to shut the engine off, and then we'll use the scan tool. We might go back to key on engine off, just to power it up, but we're going to close it off with a scan tool, close off the vent solenoid, and then we're going to monitor the fuel tank pressure sensor, and we should see some pressure start to build there. If not, well, we've probably got somewhat of a leak. Now it might be time to grab that smoke machine, but you understand how important the scan tool is in the initial diagnosis of this. So let's switch over to Chrysler with the ESIM systems here. So Chrysler's used natural vacuum leak detection, right? They had the NVLD system. They used the mechanical pump style system for a couple years, and then they've gone over to the ESIM here. And so this is the Evaporative System Integrity Monitor. That's what ESIM stands for. So we've got our tank here. We've got a vent and the onboard recovery, vapor recovery system here. We've got our canister. We've got our purge control solenoid. But then our actual vent and the measuring device here is included in this ESIM assembly. So I've got a couple of ESIMs with me. Got a brand new one here sitting on the table, but I've also gone ahead and pulled one apart here. And so as we look inside of this, you'll notice that there's a couple different weights here. So it's going to go to the canister, and then we've got the fresh air inlet. So as I look at the ESIM in my hand here, you can see where it clips on the canister. So we've got the unit here, it's going to get clipped into place, and then we've got our fresh air vent coming right here. Well, inside of there, we've got a couple different components here. So we've got a large weight, we've got a small weight here, and then we've got our switch contacts and a diaphragm. And so with these weights in place, this should be sealed off. And in a completely sealed system, it's going to draw the diaphragm in and close the contacts, letting the control module understand we do have a sealed system here. So during refueling event, somebody's putting gas in the tank, we need to get rid of all that air. So that's going to come out here, and it's going to go through the whole canister, and we should have fresh air coming out at this point because the canister has caught, or that charcoal's caught all the hydrocarbons there. So it's going to come out to this, and as it comes through, it's now going to lift this large weight off of its seat and exit into the atmosphere. So there's multiple passages through here. And then if we're in a purge situation, so we've got the purge solenoid up on the engine, it's going to be drawing a vacuum. It will apply vacuum to the whole system, drawing fresh air in through, and it will draw through, lift the small weight off, and go through the canister. So that's where these weights are. And it's very important, and this is one of our tips here, I'll say this multiple times, make sure it's oriented properly. There is an alignment tab here, but I've seen people get aggressive. When you think it's obvious, don't challenge technicians, right? We can always find a way to improve upon it. So as we look at some of the internals here, let me kind of pull this unit apart. And so as you look at this, first thing you'll notice is the diaphragm here itself. So as I peel this diaphragm back, the electrical contacts are inside of there. They've now just fallen off as I pulled this apart. But then as I flip this, we can see our two different weights. So here's the weight on the bottom, here's the weight on the top, and then we've got our passageway through the middle here. And so if I installed this upside down, they're going to be naturally blocking the air coming through this. So it's very important that we install this in the correct orientation here. And there's my weights falling on the table. So once again, make sure that it's properly oriented here. It should be pretty obvious, but pay special attention when you remove the previous unit. And one question that comes up quite often from technicians when I'm working on one of these Chrysler systems, you lose the ability to mechanically or electronically shut off the vent path like you did on a GM. There's no vent solenoid here. And so what we need to do is either use, we don't want to pinch this particular line here, but if there is this soft rubber hose here, pinch it off with maybe a vice grips, or maybe even better off is to pull this and cap that off. And so we can make sure that we've got it sealed there. And then as we look at some of the scan data here, this is a good area to zoom in and look here. So we've got the engine speed and RPM. We can see we've got the vehicle idling. In the second line, you can see the purge being controlled here. And so it's ramping up, pulling a purge. And then in green on the third line here, we can see that switch inside the ESIM is going to be closed here. And so one thing I want to call out, or you can see the note here, this purge switch, or this ESIM switch is very sensitive. There's small contacts in there. They might bounce at time. And so if you see this little blurb here, it might be indicative of some weak contacts there, but I'm going to make a note of it at this point. I'm not really going to condemn the ESIM based on this part here, but hopefully now you get a good illustration of what's happening with the scan data. So whereas GM started with a large leak test, if it passed that, then it would go to the small leak test. Now Chrysler's going to kind of flip the script. they're going to go for a home run every time. They're going to start by testing for small leaks first. If it passes that, well, obviously there's not a large leak, so it's good. And if it fails the small leak, now it will go for a large leak test. So here's the engine off test on the Chryslers. The weights are going to seal the system inside of this ESIM unit here. And then, so we should see 1 inch of water due pressure or vacuum due to the temperature decrease here. So if the switch closes, the contacts close based on this diaphragm movement here, now it equals a pass. Now, if it doesn't, now we need to go to the next step here and do an engine running test here. And so if the small leak didn't pass, that's the only time it's gonna be looking for a large leak test here. So the vehicle running, it's gonna command the purge solenoid on, drawing a vacuum on the system here. And remember, we've got the weights in here kind of closing it. And so with a purge command on, should see the switch close. That's gonna indicate that the purge is working properly and there's not a monster leak in the system here. And so if the switch doesn't close, now we're gonna hit a P0440. So yeah, hopefully you have a better understanding of the ESIM systems on a Chrysler and how it's different. You know, we don't have the electronic control of that vent solenoid like we did with the General Motors. And so how are we gonna test these? Well, I'm gonna use a scan tool. Here's an example using the Y-Tech, but again, I've got top-down, Autel, Snap-on here, and they've all got great testing capabilities. So I'm gonna use the scan tool to actually force the test to run. Yes, I'm gonna force the monitor to actually happen there. Keep in mind, if you're gonna be back probing or using a lab scope for the switch here on the ESIM, it's just 2 wires, right? So you can read across them. There's some versions, early versions, might be 4.5 volts or 0 volts. And so it'll go between those two. Later ones will be 12 volts. And so there's no hard rule of thumb, but again, look in service information. But my point here is don't be surprised if you see one that's 4.5 volts, one is 12. It's probably the correct system for the vehicle you're working on there. And so we always want to pull a manual vacuum on this. And again, once we pull that manual vacuum, don't forget we have to manually seal this off, but the switch should read 0 at that point. So let's kind of wrap up our time here talking about Toyota. Now, Toyota's, when I got into the industry, there was a lot of confusion with the multiple systems. Toyota and Honda weren't my favorite EVAP systems to diagnose, but they got significantly better, or probably more mainstream or familiar, like some of the General Motors applications or even Ford. And so today's vehicles, I actually have a 2024 RAV4 here in the shop today, and that's going to use electronic pump style system here. And so as we take a look at the canister here, it's kind of buy one, get one. It's got the electronic pump on here, which the vent assembly is incorporated into that, as well as the canister itself. And so the purge is really the only component, and obviously the fuel tank and the lines, but really a lot of the other stuff is inside of it here. So we've got electronic vacuum leak detection pump on this canister here. So let's quickly dive into how this system operates here. So as we look at the schematic, I'm just gonna say when the engine is running and the PCM is not running a purge flow test, the vent valve is gonna be open or de-energized, kind of like what we see on every other manufacturer. Then the PCM will control the purge flow with a pulse width modulated signal to the purge valve, and then the fresh air will flow into the pump assembly through this open vent. So if we look at the red arrows here, you're gonna kind of see how the air is being drawn into the vapor canister here. So really nothing different here. We've got the purge being applied to it, and it's gonna draw fresh air in. So now to run the purge flow diagnostics here, when the engine's running, the PCM is gonna close or energize, just like we do on other manufacturers here, the vent valve. So that's inside of this leak detection pump assembly, and turn the purge valve on. So if a sufficient level of vacuum is achieved, now this is to be determined based on temperature, fuel levels, etc. This portion of the purge flow in the monitor will test. So then when it comes to the rest of it here, now we have to do the leak diagnostic. So first thing that's going to happen is the vehicle is going to determine the barometric pressure. What's the atmospheric pressure like here? It's going to determine what a 20 thousandths leak looks like. So it's got a self-calibrating orifice inside of this device. It's going to use that as a reference. That's going to perform a leak check. How did it stack up against that? That's going to verify the purge operation, make sure it does what it's supposed to be doing. And then once again, it will verify what a 20 thousandths leak looks like. So it's kind of like if you're doing a test on an electric vehicle, we talk about a live, dead, live test. This is gonna, what's a 20 thousandths leak look like? What do we have on the vehicle? What's a 20 thousandths leak look like? So it's gonna verify it there. So as we look at the leak detection system here and what it looks like, let's dig in. And so again, this is done with the vehicle off. So at a certain point, who knows what time it's going to be, the engine control module will power up, and with the vent valve open, it's going to read the barometric pressure from the internal pressure sensor on the pump assembly. So you can kind of see that in the bottom of the blue box here. Next, the engine control module will turn the electric motor on the pump assembly on. And this is going to cause air to be pulled through that 20 thousandths orifice. You can kind of see it there on the drawing. And so it's going to pull air through it. As it's doing so, the sensor is going to monitor what that 20 thousandths leak looks like. So it will kind of draw itself a picture here. And keep in mind, this is happening while the vehicle's parked. So any of you that have a Toyota, you might walk out in the middle of the night and hear some sounds in your garage. Again, this might be the vehicle doing what it's supposed to be doing. Now for the next step, the actual leak check is going to occur with the engine control module leaving the motor running, and now it's going to close that vent valve. The motor will then attempt to create a vacuum in the EVAP system. If the vacuum level reaches a certain calibrated point, which is obviously going to be less than that reference check we just did, now the system is likely sealed and it will pass. Now the next test is to verify that the purge valve is actually connected to the rest of the system. So whereas other manufacturers were doing a complete purge test, this is still going to be done in this key off state. So with both the motor and the vent valve still connected on, so we're closing off the vent and we're drawing a vacuum in the vent motor. Now the purge valve will be commanded on. Now keep in mind, the vehicle is actually off, so we don't have intake manifold at that point. It should be barometric pressure in the intake. And so by opening up that purge valve, we're now able to draw fresh air in. So our pressure should actually rise, right? We had a vacuum, now we open up the purge. That's kind of like a leak there. And so that's where our pressure is going to change. Now, once it passes that, the next step will be to do that second 20 thousandths reference check. So the ECM will open the purge valve momentarily to check its operation, and then the measured pressure should go up very quickly, and then the purge valve will be commanded closed once again. The electric motor will be running, and the vent valve will be open. At this time, we should see another 20 thousandths reference value acquired, and as long as it matches the first one, and our leak check was lower vacuum than that, now it's going to probably pass the test. So there's a lot going on with this Toyota system, but it's really quite simple. And so once again, I'm going to be using my scan tool here. And so this is a lot of the scan tools, and I challenge every one of you next time Toyota comes in, whether it's for an oil change, tire rotation, suspension work or whatever, familiarize yourself with this test. Now, in the older Toyotas, there was an 11-step test. This is a much quicker and simpler test here, but it's available in a lot of scan tools, so you run through them. And then when the test is done, it's going to say this test is complete. Sometimes we're going to have to go into trouble codes and verify if a code was set or not. So that's where it's important to understand the monitor. And we need to, in many cases, probably clear out the trouble code, run the test, and then recheck to see if a code is set. Or if you want to look in mode 6 information, you can find out some more stuff there. Sometimes we're going to want to do some manual testing, so I might want to turn on just the electric pump. These things do go bad over time. One thing I see a lot is the debris in the 20,000s orifice. You can't replace just that orifice, so you're going to be replacing this entire assembly here. And then, as I'm commanding this, just like I do in other vehicles, many times it's super nice to just watch the live data as you're running through the different tests here. So once again, it comes down to familiarity with the system. And so practice, practice, practice. This isn't something that many of us just quickly learn overnight. We're dealing with vapor and with gases. It's not something like a tie rod on that you can touch or brake caliper. And so that's where it takes a lot of practice and just understanding what known good is and how these systems work properly before you get a broken car showing up in your bay. So as I kind of wrap up here, I want to walk through those different steps here. So here's a recording of me doing the test. So we've got the vapor pressure gauge. So this is our pressure reading. Here's the vent solenoid. Here's the vacuum pump. And then here's the purge. So let's kind of go through this. Well, so if I back up, step 1, that's where we're determining atmospheric pressure. So that's kind of the first step here. What is our benchmark? Now we can see in step 2, we've drawn a little bit of vacuum here. The vacuum pump has been turned on. So this is our 20 thousandths leak check. It's being drawn through that orifice. Notice our vent solenoid is still open. So we're just drawing through that orifice. So this is our benchmark at this point. Now, as we go into step 3, now we can see the vent solenoid has been closed. And so now with the sealed system, once it closes that, it's going to, we see a pressure increase back here because now it's kind of rerouting inside of that unit and it's connecting it to the rest of the tank, etc. But now it's going to be drawing that vacuum. This vacuum pump has been running this entire time. It's going to be drawing this vacuum here. And so without putting any special markers in here, I think you'll agree with me that this has dipped further than that 20 thousandths reference point. And so we definitely have a sealed system at this point. But now step 4, this is where the purge solenoid is going to be turned on. Once again, I want to remind you, the vehicle's off. So there's not intake manifold vacuum. That car's been sitting at rest for probably a couple hours. There's no manifold vacuum stored there. So by opening up the purge solenoid, it should release all the negative pressure or the vacuum in the system. And lo and behold, it did. So we're good there. Now it's going to do the 20 thousandths leak check again. It doesn't need to do it for as long as the times it did previously, but it passes again. So leak check, true leak detection, leak check. And so this is a true passing system here. And so once again, it wants to turn everything off, see it go back to atmospheric pressure. It's all set. So I'm going to kind of leave you with this last one here. So I've just shown you known good, but we need to show you known bad. And so when we do this in a live class in front of a live audience, this is a great discussion point here. As we can see our leak check, but then look at, or that's our orifice leak check, I'll say. Here's our true system leak check. What's going on here with this? So feel free to add your comments in the box there. We've got Patrick and Corey working in the background here, but what do you think's going on here? So if you guess that this is a leaking system, you're absolutely correct. And so we've got, we have to determine where the leak is. Is it the gas cap? Is it a faulty unit here? Is there a crack somewhere? Is there a seal? That's our next steps. But we've just verified that this is a leaking system by using the 4-step process. So that kind of wraps up here. I've only covered 3 manufacturers. There's a lot more specifics on different manufacturers. But a couple of key takeaways from this session is you want to understand the base EVAP fundamentals. Hopefully you have a better understanding of the ideal gas law. When we have a fixed container, if the temperature changes, the pressure is going to change with it. And then hopefully you have a better system understanding of certainly GM, Chrysler, and Toyota here. And then, one of my final points is we always need to retest after the repairs are done. And so, run the monitors itself, force the test to happen. Don't just install the part, clear the codes, and hand the keys back to the customer. You might be right, but if you're anything like myself, it could come back too. So I'm going to verify our repairs here. Before we pull up the questions, I just want to remind you, if you're looking for more resources on this, go to our Standard Brand YouTube channel. We've got a lot of great information about our EVAP products, diagnostic tips. We've done a couple of these power hours on different styles of EVAP systems. As I mentioned, I previously done the turbocharged one. And so you can find all that information at our Standard Brand YouTube channel. And then if you're looking for more information, always go to standardbrand.com. You can find out more about the complete EVAP program. You can look up specific part numbers for the year, make, model you're working on. Got some great articles, additional information there. So, all right, well, before I wrap it up here, I've seen a couple questions come in, and I've seen the guys have addressed some of those, but let's go at a couple of them.
Yeah. Hey, Ryan, so it looks like you caught somebody's attention there towards the end with that last little bit as you were wrapping up, because Chad wants to know, what program was it that you were just using or showing that you were using for that graph scan data?
Yeah, absolutely. So let me back up here. So this is ScanShare. So scanshare.io. You can go to that in your browser. Just type in scanshare.io and you'll go to this website. Now there's a free version which allows you to upload your scan data. So we always encourage technicians, as you're in a test drive, it's hard to watch the scan tool and drive. It's illegal in many states as well. So we always encourage technicians to record the information, but then you can go back to ScanShare and you can upload information from various tools to the site. And then you can open up your PID list and you can graph them. A lot of cool stuff you can do there. For a minimal charge, there's some additional stuff you can do there. There's a huge library of scan and scope data there as well. So scanshare.io was where I got that from.
Very good. Thank you, Ryan. And then this is a great question because you went through multiple different systems here. Todd was asking, in your opinion, what is the most common of EVAP lead component that you see fail?
Yeah. What's the most common? Well, this is a true stump the chump moment here, but I'd say, we still see a ton of gas caps. And so that's where I always encourage technicians not to just go out and the first thing you do is click it, run your self-test and go through those. And then, gas caps, a lot of purge solenoids as of late too. And so, if you have a faulty purge solenoid, which I don't actually have one here with me at the moment, always when you're done with it or you take the old one off, tap it upside down and see if any of the charcoal comes out of it. Quite often we see customers go click, click, click when they're at the pump trying to squeeze those last couple pennies in because they're OCD and they want to make sure they get it up there. They might flood the canister and we don't want liquid fuel inside of the canister. So that degradates the canister, it falls apart, and the next purge operation is drawing some of that stuff into the engine. So if you ever take a purge solenoid off and tap it upside down and debris comes out, you need to replace the canister at that time, as well as flush and or replace the lines there. So good. I've seen the guys answering a bunch of other questions here. So thanks again for tuning in, and we look forward to seeing you at the next Standard Pro Training Power Hour.